like to begin by giving some brief introductory remarks. And as our tradition goes, I would like to call the president of the academy, also the past presidents of the academy, vice presidents of the academy, fellows of the academy, your excellencies, distinguished guests, our very dear students who have made the time to be here, ladies and gentlemen, and all protocols observed appropriately. On behalf of the fellows of the Ghana Academy of Arts and Sciences, Ghana's premier learned society, I welcome you all to this evening's inaugural lecture on the topic, Significance of Terrestrial Impact Structures, a case study of the Lake Bosumtwi Impact Crater, Ghana. Briefly, I'd like to mention that since 1973, newly elected fellows have had to deliver an inaugural lecture as part of their responsibilities as fellows of the academy. And in this brochure, we have listed inaugural lectures delivered since 1993 for information. I would also like to mention that this evening's program is being streamed live via Zoom, Facebook, as well as on the Academy's YouTube page. We are happy to mention that sponsorship for this program has been made possible by the speaker, our distinguished lecturer for this evening, Professor Sylvester Kojo, Danuor, FGA. The speaker also would like us to acknowledge the following individuals and organizations who have made immense contribution towards this program. So I would like to mention now Professor Edmond Dele, Paramount Chief of the Nandor Traditional Area, Mr. Ambrose Derry, Minister of Interior, Member of Parliament of the Nandom constituency, Dr. Wilfred Enim Odame, Chairman of the Governing Council, Accra Technical University, members of the Governing Council, Accra Technical University, the Vice Chancellor, Pro-Vice Chancellor, Registrar, and Finance Director, Accra Technical University, Professor Leonard Amekuji, Provost, College of Science, Kwame Nkrumah University of Science and Technology, Mr. Doria Danuor, Registrar, NAFTI Campus of University of Media, Arts and Communication, Accra, Dr. Daniel Boama, former Director General, Ghana Geological Survey Authority, Mr. Isaac Mwimbele, Director General, Ghana Geological Survey Authority, Mr. Nicholas Opoku, Head of the Seismology Division, Ghana Geological Service Authority, President and Executives, Ghana Institution of Geosciences, Dr. Cyril Boatin, Lecturer, Department of Physics, KNUST, Mr. Sylvanus Ahulu, Lecturer, Department of Health Sciences, University of Ghana, Legon, Mrs. Paulina Amponsa, University of Nuclear and Allied Sciences, Kwabenya, Dr. Dominic Eric Forson, Department of Physics, University of Ghana, Legon, Dr. Isaac Opong, Petroleum Commission, Accra, Mr. Patrick Amankwa Menu and Mr. Collins Okra, Water Research Institute, CSIR, Accra, Mr. Forson Jotos, Scientific Coordinator, Ghana Science Association, Accra, and Professor R. White Tamaklo, Head of Physics Department, KNUST. Professor Danuor would also like to recognize his family, his wife, Mrs. Danuor, daughter and husband, Mrs. Josephine Danuor Donko, and Mr. Edwin Donko. Now, kindly permit me to introduce the chairman for this evening's event. The chairman is the vice president of the African Union Kwame Nkrumah Award for Women in Science. Professor Kwache is also the 2019 laureate for the Clara Self-Made Ludlow Award by the American Society of Tropical Medicine and Hygiene. And I'm particularly pleased to mention that Professor Kwache was recognized by Women's World Day 2021 as one of 7 women in science who have made contributions to change our world for the better. I think our chair deserves a round of applause at this stage. So, ladies and gentlemen, without further ado, your chair for the evening, Professor Kwache.
Good evening. Assistant Honorary Secretary, Professor George Obingagi, thank you very much for those wonderful remarks. President of the Academy, Vice Presidents of the Academy, past Presidents of the Academy, Vice Presidents of the Academy, also the past Vice Presidents of the Academy, Fellows of the Academy, present and those online, distinguished guests, our special guest, Honorary Derry, who is here with us, and all the very important distinguished guests with us, students, media, ladies and gentlemen, all protocols observed. Good evening again. Tonight, my task is quite simple, and that is to introduce our speaker for tonight's inaugural, Professor Sylvester Danuor, who is going to talk to us about the significance of terrestrial impact structures, a case study of Lake Bosumtwi, impact crater, Ghana. Now, I've had the opportunity to visit Lake Bosumtwi, and I found it quite fascinating. So for me, it's particularly interesting that we're going to have a man who has spent years studying this wonderful crater. And so I'll give you a little bit of the profile of our speaker for tonight. He is Professor Sylvester Danuor, who is a full professor of physics at the Department of Physics at KNUST. He had his elementary and secondary education in Nandom in the Upper West region. He had a first degree in physics from Kwame Nkrumah University of Science and Technology in Kumasi in 1982. Then a master's degree at the Institute of Meteorology and Geophysics of the University of Frankfurt, Germany, from 1986 to 1992, under the sponsorship of the German Academy Exchange Service, DAAD. Then a physics as a joint sponsorship, then PhD as a joint project between KNUST and the universities of Frankfurt, Kiel, and Munich, all in Germany, during which he carried out research on the Lake Bosumtwi impact crater near Kumasi. His major research focus is on the geophysics and paleoclimatic significance of Lake Bosumtwi impact crater, from which he published several articles in peer-reviewed journals and attended a number of scientific conferences at both national and international levels. Through the Lake Bosumtwi research, Professor Sylvester Danuor became one of the facilitators of the Lake Bosumtwi International Scientific Drilling Program, which undertook the first ever deep drilling of the crater to recover sediments and hard rock for various geoscientific studies. Now, from 1992 to 2004, he was the coordinator of the Ghana-German research project on the Lake Bosumtwi crater, as well as the International Continental Scientific Deep Drilling Project of the Bosumtwi crater. He was also a member of the Lake Bosumtwi Basin Development Planning Committee, which was established under the Ashanti Regional Coordinating Council from 2000 to 2012. He was also a member of the Otumfuo's Committee on Lake Bosumtwi, which is at Menchia Palace, 2004-2005. He initiated the introduction of the Meteorology and Climate Science program at KNUST through a British Council England-Africa Partnership collaboration with the University of Leeds in UK. He therefore became the first coordinator of the Meteorology and Climate Science program from 2007 to 2009. From 2009 to 2011, he was the national president of the Ghana Science Association, quite an achievement. And he has served as a visiting scholar, research scientist, at the geophysics and related departments of a number of foreign universities, including the universities of Frankfurt, Munich, and Kiel, all in Germany. Others are the University of Toronto, University of Alberta, and the University of Waterloo, all in Canada. Then Stanford University in California and Duke University in North Carolina, all in the USA, and the University of Leeds in the UK. He is currently a government appointee to the Nandom Municipal Assembly, Upper West Region, and the Governing Council of the Accra Technical University, ATU. He was elected Fellow of the Ghana Academy of Arts and Sciences in June 2014. He is married to Mrs. Alosia Danuor, with whom he has 3 children. Josephine, who is a land management officer at Newmont Ghana Gold Limited. Frederick, who is a petroleum engineer, ENI Ghana Limited. And Patrick, who is a PhD student in South Korea. So this is the enormity of the profile of our speaker for tonight. Round of applause.
Thanks very much. Thanks very much, Madam Chair, for the beautiful profile of myself. First of all, I would like to welcome in a special way my MP for the Nando constituency, Mr. Andrews Dere, and then also now Professor Bruce Banoy Yakubu of the Department of Earth Science, University of Ghana, Lagos. Okay. Hello. Okay. You are all welcome to this presentation. Indeed, I'm glad that when you look at the title of the presentation, you don't see any direct physics word. You know, when a physicist is coming to talk, people think of big words like quantum scattering or quantum dynamics or something like that. But when you look at the title, you don't see any physics word. So I'm very happy about that. So let us see what will unfold. So the topic, as stated, is significance of terrestrial impact structures, a case study of the Lake Bosumtwi impact crater, Ghana. So what is it all about? So what will unfold will be very educative to you. So I indulge your listen attentively, and at the end of the day, you carry away something home. So the outline of the presentation is as follows. First of all, I'll give you an introduction about craters. What are craters, and why should we know about them? Then the aim of the inaugural lecture and the outline of the research. And then I'll talk about overview of the formation of impact craters, and then the research work that I have conducted at Lake Bosumtwi. This will be followed by frequency of impacts in relation to size and energy of the cosmic body, and then how the research findings can be used to promote ecotourism in the area, and then finally conclusion. Now, general introduction. Impact craters on solar system bodies. Craters are the dominant landforms on the moon, Mercury, and many other solar system bodies, as we can see on the slides. They are formed by collisions between smaller bodies in the solar system with larger ones. So these are various craters, as you can see them. We also have impact craters on the Earth. For instance, we have Meteor Crater, Arizona, which is very famous, well studied, and known after its discoverer, the Mr. Barringer, and therefore the crater is called Barringer Crater, with diameter of 1.2 kilometers. And then we have the Wolf Creek Crater in Australia, diameter 880 meters. And then the Fredefort crater in South Africa. That's the world's largest impact crater so far, and the second oldest. Usually, when we state impact craters, we give the diameters because, as you later on find out, it has something to do with the energy that is released when an asteroid strikes the ground. And usually, the craters are surrounded by a rim. They're always surrounded by a rim, which is made up basically of ejected materials during the impact of the asteroid. You must have heard of the Apiati explosion, which is still fresh in our minds. So we have other types of craters. We call them other explosion or volcanic craters. So the Apiati explosion, which happened on 13 January 2023, is still fresh in our minds, and that is a crater. We also have volcanic craters, and usually these craters are characterized by a vent from which material is ejected from time to time. Now, what is a crater? The word crater from Greek means a cup or a bowl, and is a term used to describe the approximately circular rim depressions observed in abundance on the surfaces of solar system bodies, as you can see on the right-hand side of this slide. These are craters which are found on a solar system body. What is the origin of these craters? The origin of these features was a hot debate in the past, according to Melosh in 1989. But through planetary exploration and extensive lunar research, astronomers and planetary scientists recognize that practically all craters visible on the moon were of impact origin. It is now generally accepted that most craters on the moon and other solar system bodies are produced by the impact of asteroids, fragments of asteroids, and comets of different sizes. The slide shows an asteroid that is heading towards the Earth, and because of the great speed or the high velocity and the friction in the atmosphere, the asteroid is like a bomb. It's a fireball before it hits the ground. Now, when we look at the moon, we see that its surface is dominated by impact craters. So the question is, what about the Earth, this solid Earth that we are working on? So these findings on the moon indicate that the Earth, over its history, must have been subjected to an even higher impact frequency than the moon because of its larger gravitational cross-section. However, due to active geological processes on the surface of the Earth, such as weathering, erosion, sedimentation, and tectonic activities, these impact craters tend to be covered. That is why we cannot just get up and see them anywhere, but they are there, buried under sediments and even under the water in the oceans. They are there. And therefore, the study of impact structures is consequently of great importance in our understanding of the formation of the Earth and then the planets. On Earth, impact craters form when a cosmic body, an asteroid, comet, or meteorite, also known as a projectile, bolide, or impactor, hits the ground, either on land or in the ocean. The term impact structure is usually used to describe very old and highly eroded impact craters, whilst the term impact crater refers to uneroded, well-preserved impact craters. However, the two terms are used interchangeably, as you will see in the lecture. So the slide there shows an asteroid which is heading towards the Earth at a high speed, and as usual, it's like a bomb. It's a fireball which is coming to hit the Earth. Significance of impacts. Why should we know about impacts? An increasing number of geoscientists are now coming to appreciate the importance of impact events and the extent of their influence on the geological and biological history of the Earth. It is now an established fact that a meteorite impact caused the extinction of the dinosaurs and other species about 65 million years ago, popularly known as the Cretaceous Tertiary or KT boundary event. The 200-kilometer diameter Chicxulub impact crater on the Yucatan Peninsula in Mexico is associated with this event. So the slide there shows an asteroid that is heading towards the Yucatan Peninsula. That's heading towards the Yucatan Peninsula in Mexico, and this is the location of the Chicxulub impact crater that caused the extinction of the dinosaurs. An impact leads to an explosion, and therefore meteorite impacts are therefore possible destroyers of civilization. Impacts can wipe out humanity and other species. An impact leads to an explosion which will lead to what? Hot materials and a lot of dust thrown into the atmosphere. And when that happens, the sun can be blocked for several years, as we have learned from the Chicxulub impact, which caused the extinction of the dinosaurs. So when the sunlight is blocked, definitely photosynthesis will come to an end, and therefore all living things will perish. The large planetary science community sees impacts as the process that help form the solar system and is still modifying the planets. Now, currently, about 200 impact craters have been recognized on Earth. When you look at the map, you see that Africa, we have 20 confirmed impact craters. South America, we have 11. And a number of craters are concentrated elsewhere on various continents. There are two reasons for this. First of all, some of the areas are cratonic areas where geological activity is not very pronounced. For instance, they are resistant to geological activities, and therefore the craters are preserved. The other thing is that in some of these places they have well-developed programs for research into impact craters. When you look at Africa and South America, though we are also in cratonic areas, we don't have much research in these areas. That is why the number of craters there discovered are less. Now, historically, the concept of impact cratering is not given much consideration in classical geological studies. Rather, endogenic processes of potential hazard, such as earthquakes, volcanoes, tsunamis, and tectonic activities, are given preferential treatment when it comes to research in the geosciences. However, the interest in impact cratering is growing tremendously, and impact craters are discovered every time. The aim of the inaugural lecture. The aim of the inaugural lecture is twofold. First of all, to educate and inform the general public about the importance of planetary sciences and the existence of planetary objects that can hit the Earth with catastrophic environmental consequences. A clear example being the Bosumtwi crater near Kumasi, which was formed by a meteorite impact about 1 million years ago. It is located in the Bosumtwi district of the Ashanti region. The words Bosumtwi with U or Bosumtwi with O, which are used synonymously in literature, will be explained in the lecture. Secondly, to communicate my research work and how it can benefit society. Now, my research work at Le Bosumtwi, an outline of the lecture. My research work at the Le Bosumtwi crater started from 1999 to date, during which I have been involved in geophysical, geological, and remote sensing investigations, sometimes in collaboration with local and international partners, including foreign universities. After giving some background information on the Bosumtwi crater, the lecture will give an overview of the formation of impact craters and the scientific questions that are needed to address, to be addressed in connection with impact crater investigations. The lecture will look at the origin of Lake Bosumtwi, oral history, and scientific hypothesis. The lecture will then dwell on the geophysical investigations that have been carried out at the Bosumtwi crater to determine the subsurface structure of the crater, and in particular, the tectonic disturbance of the area, which poses some environmental concerns. The lecture will also look at the frequency of impact events in relation to the size and energy of the cosmic body. For example, the presentation will address questions such as, when did we have large impacts with huge amounts of energy released? And when do we expect large impacts, or what is the interval for large impact events? Where does the Bosumtwi meteorite fit or lie in these considerations? Further, the lecture will stress on the need to use the research findings to promote the educational and ecotourism potential of the Bosumtwi crater. Now, background information on the Lake Bosumtwi impact crater. The Lake Bosumtwi impact crater is located about 30 kilometers southeast of Kumasi, as shown in the map here. And the crater has a rim to rim, surrounded by a rim. The crater has a rim to rim diameter of 10.5 kilometers and is occupied by Lake Bosumtwi, which has a diameter of 8 kilometers and a maximum depth of 75 meters. So when you look at this diagram, Abono, which is the most popular community that people normally visit, is seen there. Now, the crater is the youngest, in geological terms, large and well-preserved impact crater on Earth. And it was formed 1 million years ago in Brimian rocks, which are about 2.2 billion years old. The crater rim has an elevation of about 250 to 300 meters above the lake level, and the lake itself has an elevation of about 127 meters above sea level. Where this pillar is located is at the second highest point on the crater rim. Now, on digital elevation models, the Bosumtwi crater is found to have an inner rim with a diameter of 10.5 kilometers and then an outer rim of about 18 to 20 kilometers diameter. And these topographic features are basically ejected materials formed during the impact. And to the southeast of the crater, we have the mountain range, which is coming all the way from Obuasi to Konogo and Mapo. So this is the Obuom range, which is made up of Takoyan rocks. And you see that the crater itself was excavated in Brimian rocks. So this is the lake, the crater, and these are the Brimian rocks, which are 2.2 billion years old. This is still a digital elevation model of the crater showing the outer rim and then the inner rim and then the the mountain range. Now, the Bosumtwi crater is also associated with the Ivory Coast tektites. And tektites are actually glassy materials which are formed when rocks which are melted on impact and splashed out into the atmosphere cool so quickly that crystals or the minerals do not have enough time to form, and therefore they appear glassy in nature. So such materials were found at a location in Ivory Coast about 250, about 250 to 300 kilometers west of the crater. That's where the materials were found, and their source was traced to Bosumtwi. And later on, during deep sea ocean drilling, microtektites were also recovered off the coast of Ivory Coast, and they were found to be related to the tektites found on land in Ivory Coast, meaning that they also came from Lake Bosumtwi. Now, Lake Bosumtwi is surrounded by about 24 communities. 24 communities are living along the lake. And when you are going there, this is Pontanasi, this road is going to Kumasi, this is Bekwai. And then if you are coming from Accra through Ejiso, you can pass here. If you are also coming through Bomfa, you can pass here to Bekoso and come around the lake. Now, formation of impact craters. This slide shows various objects in the solar system that can form impact craters. They are remnants of bodies left over after the formation of our solar system about 4.6 billion years ago. So we need to know some definitions. For instance, what are asteroids, what are comets, meteors, and so forth, and meteorites. So asteroids are small rocky objects that orbit the sun and are found in the asteroid belt between Mars and Jupiter. So this is Jupiter and this is Mars, and this is where we have the asteroids. So usually the orbits of asteroids can be changed by Jupiter's massive gravitational influence and also by close encounters with Mars. So when that happens, the asteroids will be ejected out of the asteroid belt into the inner solar system, and then they will head towards other planets, including the Earth, and that's how they can come and hit us or hit the Earth. When a small piece is broken from an asteroid, we call it a meteoroid. This is an asteroid. So when a small piece is broken from it, we call it comets are icy bodies of frozen gases, and they are also found in the solar system in two places. First of all, they are found. First of all, they are found in a belt at the edge of the solar system. We call it the Oort cloud, and then also beyond Neptune in a belt we call the Kuiper belt. So these are the two places that comets are found. And in fact, comets are the most primitive objects left over in the solar system, and scientists believe that they have vital information about the early stages of evolution of the sun and then our solar system. Meteors. So usually we notice some shining or streak of light in the sky, and that in the night you can easily observe a meteor. So a meteor is what happens when a small piece of an asteroid or a comet or a meteorite burns up upon entering the Earth's atmosphere at great speed. And therefore, we see some fireballs or shooting stars, and these are called meteors. We know that one of our football teams is called Black Meteors. It's for this reason. They are actually shooting stars. That's why. So when any of these objects survives a trip through the atmosphere and hits the ground, we call it a meteorite. Now, when you look at these pictures, you see that when an asteroid hits the ground, it's like a bomb. You see, when it's coming, it's like a bomb. And when it hits the ground, the first materials that it comes into contact with, they become molten and are splashed out at very high speed or velocity almost equal to 3/4 of the velocity of the impactor. And that's how they can go very far and land at the Ivory Coast. And that's how the tectiles were formed. You see, they are the first materials that the hot meteorite or asteroid comes into contact with. And they are splashed out just like mud. But they fly with very high velocities, so they can go very far. Now, a little bit of physics. I've designed this lecture in such a way that I haven't gone into rigorous physics, but I must say that the underlying science cannot be dispensed with, because what I'm presenting is based on science. So we should be prepared to know the underlying science. So the impact process. Impact craters are formed by hypervelocity impact of meteorites. When we say hypervelocity, we mean cosmic velocities which are in the range of 11 to 72 kilometers per second. How do we imagine this? I learned that when a bullet is fired from a rifle, the speed with which the bullet goes is about 630 to 800 meters per second. Of course, some can be higher than that depending on the model of the rifle. Take an asteroid which is traveling at 20 kilometers per second. That is 20,000 meters per second. It is traveling, if you take a bullet, even traveling at 800 meters per second, the asteroid will be traveling 25 times faster than the bullet. You see, the asteroid is traveling 25 times faster than the bullet. When we are watching movies, and people are firing this, do we see the bullet? Do we see it? Hardly can you see the bullet when a bullet is fired. You see, so you can just imagine how fast the asteroid is moving. And therefore, when it strikes the ground, you can imagine the disastrous consequences. Okay, so the pressures and temperatures generated at the point of impact are usually more than 100 gigapascal and more than 10,000, temperatures more than 10,000 degrees Celsius, respectively. So this will lead to complete melting. This will lead to complete melting and even vaporization of both the projectile and part of the target rocks. So unless a large meteorite breaks apart during its journey through the atmosphere, usually we don't find fragments of the meteoritic body at large impact crater size, because the meteorite will be fused, will be molten and fused with the country rocks, pushed into the crater, and some thrown out. So we don't expect to find a meteorite or part of it at the crater site. So the production, the impact leads to production and ejection of materials which will form the crater rim and the tektites and impact-derived rocks, such as the suevites. These are rocks which are normally formed because of the impact of the meteorite. Now, the impact leads to the production of shock waves, which are intense, high-pressure stress waves that are not produced by ordinary geological processes. And in fact, impact cratering is a unique geologic process in that vast amounts of energy are released in a small area in a very short time, thus leading to what we call shock metamorphism in the rocks, whereby minerals are immediately transformed from one phase to the other. This is in contrast to the normal endogenic metamorphism that we know, which is a long-term process. So shock metamorphic effects include the transformation of the mineral quartz to coesite or stishovite, for which the transformation pressures and temperatures cannot be generated in the laboratory. So if we discover coesite at the Earth's surface, it means it must have come from a meteorite impact, because usually, naturally, coesite or stishovite, they are found at depths of about 60 to 100 kilometers beneath the Earth's surface. You cannot just find it on the Earth's surface. So if you see it on the Earth's surface, it means an impact has happened and the mineral quartz has been transformed into it because of the high pressures and temperatures generated. And that is where the distinction with the volcanic craters will come in, because the temperatures and pressures associated with volcanic eruptions, they are very low. For instance, during volcanic eruptions, temperatures rarely exceed 1,200 degrees Celsius as opposed to 10,000 from the impact. And the pressures too are 2 gigapascal and below as opposed to 100. So the two effects are different. So when we discover shock effects or shock metamorphic effects at a place, it means it is only impact that has caused that. Volcanic eruptions do not produce shock metamorphism. So we use it as a way of distinguishing between a volcanic crater and an impact crater. And also, when the projectile strikes the ground, the shock waves that are produced, they cause shattering, fracturing, and brecciation of the rocks, leading to changes in the physical properties of the rocks along radially from the impact point. You see, so it is these changes in the physical properties that the geophysics is used to map. For instance, if there is no meteorite impact, the physical properties of the rocks will be uniform. But when an impact occurs, the rocks will be shattered or fractured, and then their physical properties will change. And therefore, we always say that it is an anomaly. It's a deviation from the normal. So you use the geophysics to map these sort of changes and then analyze your results. Now, the characteristics of impact craters are the consequence of the enormous kinetic energy released into the target rock when the meteorite strikes the ground. In particular, the impact leads to changes in the physical and lithological properties of the rocks. So impact craters, by virtue of their formation, are associated with natural resources. For instance, mineral deposits. We have heard of impact diamonds at other impact craters. And also hydrocarbon deposits. For instance, in the Gulf of Mexico, where the Chicxulub impact took place, a lot of oil drilling, exploration is going on there because of the impact. Now, energy released by the impact. The energy released in an explosion is usually measured in terms of TNT equivalent. It's by convention. TNT is a powerful explosive substance, and the abbreviation stands for trinitrotoluene. For example, for each gram of TNT exploded, 4.184 kilojoules of energy are released, or 4,184 joules of energy are released. So, for example, how much energy was released by the Apiati explosion that caused the flattening of the town? This can be easily calculated if we know the amount of explosive that the truck was carrying in terms of how many kilograms, how many tons was it. We can easily use it to calculate the amount of energy that was released by using this convention. It's an international convention for calculating the energy released during an explosion. So, examples of meteorite impacts and energy released. It has been established that a meteoritic material of 6 meters diameter will release as much energy as the Hiroshima atomic bomb, which is 20 kilotons of TNT, or about 8.3 times 10 to the 13 joules of energy, when it hits the ground at 20 kilometers per second. And also, a meteorite of diameter 250 meters will release about 1,000 megatons of TNT. This is about 50 times the Hiroshima atomic bomb. And it will create a crater about 5 kilometers in diameter. So the question is, the Bosumtwi crater, which is 10.5 kilometers in diameter, how much energy was released? So that's what we are going to find. Now, morphology and structure of impact craters. The formation of impact craters is a complex interaction between the projectile, the target rocks, and the shock waves. And that's where the rigorous physics is. I'm not going to go in there. But we can say that impact craters have 2 basic morphological forms. We have the simple crater, which is usually a small bowl-shaped depression with diameters up to about 2 to 4 kilometers. And then we have the complex crater, which is usually characterized by a central uplift and has a larger diameter. So this is the morphology of a simple crater. This is a bowl-shaped depression, fractured target rocks, and then the broken materials will slide back and fill the crater. It will contain some shocked materials and melted rock fragments. Later on, sediments can come and fill in, then water, depending on the situation. Then we also have the complex crater. For the complex crater, During its formation, so much material is excavated that the lithosphere rises to compensate for the mass deficit. So that's why there is a central uplift. We usually call it lithospheric rebound. And you see that the complex crater has a larger diameter, and the rim areas are fractured and faulted, and it contains shocked materials and impact melt. Later on, sediments can come and fill it, and then water, depending on the situation. So the question is, what is the form of the Bosumtwi crater? Is it a simple or complex impact crater? So, scientific questions by impact crater investigations. So when we are doing investigations, what do we look for? There are 4 things that we look for. First of all, the crater morphology and structure. Is it a simple crater? Is it a complex impact crater? And what is the nature of the deeper structure? Has it got, is there faults, fracturing, and so forth? And then the geophysical characteristics or anomalies, which are associated with the impact. So these 2 are best investigated using geophysics, the first 2 of them. Then indications of shock metamorphism, which is actually a definitive proof of an impact crater. And then traces of the meteoritic component. We can also do geochemical analysis to see whether some trace elements, which we normally find in the meteorites, are present in the soil where the meteorite landed. So the 4 of them, they constitute the criteria for identification of and confirmation of impact craters. So geophysical characteristics or anomalies, what are they? You see? So the geophysical characteristics or anomalies are largely a result of the fracturing, shattering, and brecciation of the rocks caused by the shock waves. Physical properties of rocks most affected are densities, seismic velocities, and magnetic susceptibilities. The geophysical methods have been designed in such a way that they respond to some physical parameter of the rock. For instance, the gravity method will respond to the density of the rocks, changes in the densities. The magnetic method will respond to changes in the magnetic susceptibilities of the rocks. And the seismic will respond to changes in the seismic velocities of the rocks. In fact, in geophysics parlance, we normally talk of seismic velocities rather than seismic speeds of the rocks. If you go to any oil exploration company where they are processing seismic data for oil and gas exploration, the language there is what are the seismic velocities of the rocks in the area that can point to our reservoirs where we can locate our oil and gas. So seismic velocity is a language that is used in the geophysics rather than speed. Now, the effects of material damage to the rocks will be more pronounced below the impact point, for instance, below the lake. And therefore, geophysics is used to map the impact-induced changes of the physical properties. Now, gravity anomaly or signature. And I said that an anomaly means a deviation from the normal. So for impact craters, the most notable gravity anomaly is a negative gravity or a gravity low, which is usually observed over well-preserved, uneroded impact structures. And this is caused by low densities of the target rocks because of the fracturing and shattering, low densities of the materials which slide back and occupy the crater, low density sediments if they are present, and then the water. So you will normally get low densities, and that will give you a negative gravity anomaly. And usually the anomalies, they look circular in nature. But if we have very old and highly eroded impact structures where the central uplift is exposed, usually we'll record a positive anomaly because the central uplift is made up of high density rocks. For the magnetic signature, the dominant effect is a magnetic low due to a reduction in the magnetic susceptibility of the rocks. And the anomalies also are more or less circular in nature, and they manifest themselves as a disruption of the regional magnetic fabric, as I will show you an example from the Lake Bosumtwi magnetics. Sorry, I think I haven't finished one. Then the seismic signature. The seismic method is based on the velocities of propagation of the seismic waves in the rocks. And since the effects of shattering, fracturing, and brecciation of the rocks influence the seismic velocity, seismic velocities will be low at places where these effects will be more pronounced. And also, the crater morphology, that is simple or complex, will be indicated by the seismics. Now, origin of Lake Bosumtwi. Oral history has said that the discovery of Lake Bosumtwi dates back to the year 1640 during the reign of Otumfuo Opoko Ware I, the Asante Hene at the time. The hunter and antelope story. So the oral history still continued that a hunter by name Akura Bompe went to hunt in the forest, and then with his dog. Then he saw an antelope and shot at the antelope. The antelope ran into the forest, so he and the dog followed by tracing the footsteps of the antelope. And then he later discovered the antelope standing by a pond of water, presumably the lake at the time. So as soon as the antelope saw the hunter, it jumped into the pond and vanished. So the hunter believed that the pond must be some spirit or some god. That is why the antelope jumped into it. So he named the lake Bosumtwi, meaning God's antelope. And therefore, the name Lake Bosumtwi with the O there. That's why the O is there. So Lake Bosumtwi is the largest natural lake in West Africa, and is sacred to the Ashanti people. So the term Bosumtwi with U is used more often in scientific literature than the Bosumtwi with the O, which is used if you go to the district assembly or regional coordinating council level. When they are talking about Bosumtwi, they will use the word, the O there. So when you see the two of them, they are used synonymously in literature, so it's accepted. Now, scientific hypothesis about the origin of the lake. In the past, there were some controversy concerning how the lake came about. And 4 hypotheses were advanced to account for the lake. The first one was volcanic activity, subsidence followed by faulting, meteorite impact, explosive volcanic activity. And literature says that the controversy was caused partly by an incomplete understanding at that time of impact processes. Because this impact cratering that we are talking about is an emerging science. At that time, it was not very known. Even I mentioned that the origin of the impact craters was hotly debated. People didn't know exactly how they came about. But there were some indications that pointed to a meteorite impact origin. First of all, the discovery of this rock, which people thought it was a volcanic rock, is actually a rock that was formed as a result of the impact. We call it a suevite, and it contains shock metamorphic features. And the volcanic rocks do not contain shock metamorphic features. So that is one of the things that pointed to an impact origin for the crater. And also the discovery of coalzite, and also nickel-rich iron spherules, which pointed to an ion composition for the impactor or the projectile. And also the origin of the tectiles. Tectiles are formed by only hypervelocity impact of meteorites. And they were traced, you see, they were traced to Bosumtwi because other studies show that the crater rocks and then the tectiles, they had the same chemical composition, similar isotopic characteristics, and also the tectiles and then the glasses in the suevites had the same age of 1 million years, just at the time of the formation of the crater. So these are some pictures of the tectiles and then microtectiles. Now, geophysical research at the Lake Bosumtwi crater. Previous geophysical studies. So previous knowledge of the geophysical characteristics and therefore the deeper structure of the Bosumtwi crater was fairly limited. This was due to a lack of detailed measurements on the land area, inability to have access on the lake due to lack of a suitable research vessel, and therefore no measurements on the lake. And I must say that because the crater is buried under sediments and covered by water, geophysics is a very important tool because it can image the whole structure. So my task in this work was to use the geophysics to address the unanswered questions, which are the crater morphology and structure, and then the geophysical characteristics or anomalies. And therefore, the following measurements were carried out: gravity measurements, seismic and magnetic measurements, both on the land and on the lake, bathymetry measurements, that is determining the depth structure of the lake, and also measurements of some physical parameters of the rocks in the area. This research vessel really facilitated the work. It was jointly constructed by the German side and then KNUC, because we were in a research collaboration. And this picture shows one of the research missions. And the platform was named after Akura Bompe, that is the hunter who discovered the lake. So this picture also shows some of the logistical support that is needed when one has to do research on the lake. You need a lot of the local folks there to help provide labor. You need service boats. And then also at one time, this portable research vessel was brought from the US to facilitate in our research. Now, this slide shows the gravity measurement. In other words, measuring the changes of the densities of the rocks as a result of the impact. And the signs there all show how the measurements were carried out. This side is where we have the high mountain range. So that is why not so many measurements were made, but it did not affect. And then the same measurements were carried out on the lake along these lines, as well as the bathymetric measurements. Then this diagram shows how the seismic data was acquired. The red stars indicate deployment of ocean bottom hydrophones to the bottom of the lake, and the red squares indicate land seismometers. Then on the water, the vessel was moved, and then with the help of an air gun, the seismic signals were generated, and then the data was collected. And also, magnetic measurements were also carried out on the lake at all points. I must say that during all these measurements, the village, the people from the communities that we engaged to support us, they themselves were very happy with what we did, because hitherto, there was some speculation that one could not go across the lake directly, or one cannot go to certain places and so forth. So, but following us in all these aspects, they themselves at the end were very happy, confident. They told us at the beginning, but not that we were arrogant, because we were carrying out scientific work. So that's why the saying is that science is not a respecter of superstition. If you want to do scientific work, do it. You don't have to listen to superstitions. So you do it and see what you will get. So at the end, they themselves saw that they can now go anywhere across the lake. So now, results of the research. So when you look at this map, that's the depth structure of the lake. You see the maximum depth of the lake is not exactly in the center, but it is shifted southwest from the center. And also, it has been realized that the southern part of the lake has a gentle sloping bottom as compared to the northern part, which has a sharp, steep slope. So that's why I've recommended in my research, my findings, that the southern part should be developed more for recreational activities, because sometimes we hear of people drowning, because the northern part here is where most people throng to during holidays and other festivities. And sometimes you hear that somebody is drowning, especially those who are not familiar with the area, you see, because of this sharp, steep slope. So if this part is developed more also for recreational activities, at least it can minimize some of those accidents. Now, the gravity measurements also show fracturing. See, the low values show lower densities, meaning high degree of fracturing and shattering of the rocks, especially in the northern and the northwest part. Then the magnetic measurements show what is expected over an impact crater. You see, these are the regional trends, the regional magnetic trends, the lines here. And the meteorite came and hit the ground, so causing an anomaly. In other words, creating the crater, which has produced these almost circular anomalies. You see, so if the crater was not there, we should see these lines still moving northeast, southwest. That's the trend, the magnetic trend of the Bremian rocks. You see, but the meteorite has come to excavate the area, the place, and therefore causing this sort of disruption. So it's a typical example of a meteorite impact anomaly. Now, the seismic measurements show clearly the central uplift. So it shows that our Bosumtwi crater is a complex impact crater because we can see clearly the central uplift. And also a high degree of fracturing and shattering of the rocks. Because normally the seismic velocities should be about 5 to 6 kilometers, you know, maybe from somewhere down here. But we see that we still have velocities from 2 to about 5, which are very low when you are talking about solid rocks. And also, the water has a maximum depth of 75 meters, but the seismic has given us information down to about 1.5 kilometers, meaning that we have been able to image the whole structure of the crater. So somebody can not say that there is a god sitting there causing trouble. You know, in other words, those who believe in the superstitions, that there's something hiding there and causing trouble to the community, because we have seen everything below the water. When you look at it, you see that the water is just very small up there, but we have imaged all this area. So there's nothing hidden that the science has not come out with. So these geophysical characteristics or anomalies have therefore been found to conform to what is expected over terrestrial impact craters. Now, some implications of the research findings. The research findings indicate that the meteorite impact has caused a lot of tectonic disturbance of the area, which has rendered the landscape highly shattered and fractured or faulted, with ejecta materials and weak zones dominating in some of the areas, as you can see in this diagram. You see, you can see that there is a lot of fracturing and shattering of the rocks, and then faults and other weak zones. So these tectonic features have rendered parts of the landscape susceptible to landslides and massive erosion, which can cause a facilitation of the lake with disastrous environmental consequences for the aquatic life. If this should happen, it will affect the livelihood of the people there, because the major economic activity there is fishing. So the findings have brought to the fore the vulnerability of the site and the lake's ecosystem. And therefore, I've used the research findings to zone the area, as we shall see. The findings, I must say, have also cleared the myth surrounding the origin of the lake, especially the fears that there could be some gas pockets in the sediments, which could cause what happened at Cameroon in 1986, thereabout, the Lake Nyos, the explosion. So, but something like that is not seen in the findings. So at least it has cleared there. Sorry, yeah. And then these are also diagrams, courtesy some of my colleagues, which also show a lot of the tectonic disturbance in the area, that materials can easily slide down if care is not taken. So what we see here is part of the crater rim. We see that it looks solid rock, but if a road cut should be done, you will see that really the rocks are not in very good shape. They can easily slide down. Now, the results have been used to carry out a zonation of the area. So this is the community, and have recommended that 200 meters from the lakeshore should be declared a protected zone. See, and that will include, or get to the communities and so forth. And therefore, a green belt should be maintained. And also steep slopes to be avoided in connection with farming and buildings. And also controlled structures or controlled developments of structures on the rim zone. So the rim zone, as we see that it's a mountain, but basically it's made up of ejected materials from the crater. So this can easily slide down if you send up there maybe excavators and bulldozers to try to put up high-rise buildings. So these should be avoided. The geophysics results were also used in the paleoclimatic studies, whereby sediment cores and hard rock cores were drilled and taken from the crater. This is the drill rig which was deployed on the lake. And then some high-resolution seismic also shows, again, the central uplift. And then drilling too was done to 450 meters and 550 meters. Now, numerical modeling shows that the geophysics results were used to facilitate the numerical modeling of the Bosumtwi meteorite. And it has been found out that The meteorite has a diameter of about 900 meters to 1 kilometer. It was traveling at a speed of about 20 kilometers per second. And then the energy released by the impact is about 100,000 times the Hiroshima atomic bomb. So one can therefore imagine the environmental consequences at the time. Frequency of impacts in relation to size and energy of cosmic body. Impacts on Earth are ongoing. However, most meteoroids are too small to cause any significant damage or are bent up in the atmosphere. The largest impact event recorded in recent history was the Tunguska event in 1908 in Siberia, Russia, which created a big fireball leading to scorching and flattening of forests. However, there is, of course, the chance of a larger body striking the Earth. From analysis of age size and energy size distribution of impacts, it has been recognized that the very old and large impact craters corresponding to huge amounts of energy released were dominant about 2 billion years ago. For instance, the Yarabuba impact structure in Western Australia, which is the world's oldest impact crater with diameter of 70 kilometers. And then the Fredeford impact structure in South Africa, diameter 300 kilometers, age 2.02 billion years old. For these two craters, we are not told what sort of environmental devastation they caused in the past. But you can just imagine that they must have released a huge amount of energy, which must have caused some global catastrophe. We don't know yet. The one we know is the Chicxulub impact crater in Mexico, diameter 200 kilometers, age 65 million years, and that is known to have caused a global catastrophe. That's the extinction of the dinosaurs and other living things at the time. Now, this diagram here shows how the frequency of impacts against the crater diameter and the energy release. And when you look at it, you see that, for instance, the Chicxulub impact crater that was formed 65 million years ago, that type of impacts, they will always come every 100 million years. Such impacts will come, just like earthquakes, they always repeat. So such impacts will come about 100 million years' time, the interval. Then when you look at Bosumtwi, this is where I've inserted Bosumtwi. See, the Bosumtwi one, 900 to 1 kilometer diameter, creating a crater of about 10.5 kilometers. Such impacts are known to come every million years, including the Ries crater in Germany. It has a diameter of 24 kilometers and is 15 million years old. So such impacts will come around every million years. Then smaller ones like the Arizona and then the Tunguska one, the Arizona type will come once in a millennium. And then the Tunguska type once every century. Then smaller ones will come maybe each year. Some are coming every day. In fact, right now, meteorites are hitting the Earth everywhere. Maybe they are landing in your forest, but you don't know. They are landing in your forest, but we don't know. They are landing every time. So from this analysis, you see that large impacts have declined. You see, large impacts have declined. But it has been established that impactors large enough to cause a global disaster will need to be about 800 meters in diameter or more. And such impacts will come every million years. Now, this is some new items I gathered from Opera News headlines. And it says that, could a rogue planet destroy the Earth? How to stop a potentially killer asteroid? NASA issues chilling asteroid warning that makes end of world 3 times more likely. Meteorite smashes through a roof in Germantown on April 29, 2023. A 1 kilogram meteorite discovered after it smashed through a roof of a house in New Jersey, USA on 8th May 2023. And it said it landed in an upstairs bedroom. In other words, you are in your bedroom relaxing. You see, and then can come there. NASA's Center for Near-Earth Object Studies revealed that a massive asteroid, about 850 meters in diameter, to make close approach to Earth on Monday, 12 June 2023. And in fact, I read further that this asteroid will come back again in 2048, and when it comes, it will be more close to the Earth. Right now, it says that to make a close approach, and they estimated the distance to be 3.2 million kilometers. To us, we feel it is big, but in astronomical terms, it's not big. 3.2 million kilometers. That's how close it came to the Earth. But in astronomical terms, it's not very big. But 3.2 kilometers, we don't need to worry because it will not hit us. But it is said that it is estimated that it will come back closer to the Earth in 2048. How close it will come, we don't know yet. So this is an example of an asteroid that came closer to the Earth. This red orbit, that's the asteroid orbit. And the asteroid was about 3 meters in diameter. And it came close to the tip of South America in January, on 26th January 2023. And the distance was just about 3,540 kilometers. It was very close. I'm told that in fact, this is one of the closest approaches by a known near-Earth object ever recorded. But the good thing is that the planetary scientists estimated that if it had entered the Earth atmosphere, it would have bent up because it's very small, it's 3 meters. So it would have caught fire, and then it would have been bent up in the atmosphere without hitting the Earth. Otherwise, it could be catastrophic. Because we are told that even a 6 meters diameter meteorite is like the Hiroshima atomic bomb. So, ecotourism, promotion of ecotourism. So I'm now going to tell how my research findings can be used to promote ecotourism in the Bosumtwi area. The Bosumtwi crater to the scientific community is important for 4 main reasons. The first is that it is the largest young impact crater on Earth. And also it is well preserved, uneroded impact crater and occupied by a lake, which is not very common at all. Also, it is one of only 3 known impact craters with tektites. And it's an ideal site for the studies of meteorite impact processes and the paleoclimate history of tropical West Africa. The world's tektite strewn fields. Tektites, as I've explained, are formed by hypervelocity impact of meteorites only, and they have been discovered on Earth in 4 strewn fields. For instance, the North American strewn field, Central European strewn field, the Ivory Coast strewn field, and the Australasian. And there are source craters, apart from the Australasian, the others, their source craters have been identified. For instance, the Reese crater is responsible for the Central European strewn field, Sudbury crater, Bosumtwi crater, but the Australasian tektite strewn field, the source crater has not yet been discovered. So the position of Bosumtwi crater when it comes to planetary sciences is very, very important because it is one of the known impact craters that has created tektites. So all this information can be harnessed to promote tourism. So I have proposed the establishment of the Lake Bosumtwi Meteorite and Cultural Heritage Center because Lake Bosumtwi has been designated by UNESCO as a World Heritage Site. It has also been recognized by the international scientific community as a World Geological Site. And the crater has been an object of scientific research interest by various research groups, and there is the growing interest to develop the scientific aspects of the crater together with the cultural and historical sites to promote ecotourism in the area. And that is how the idea of establishing the Lake Bosumtwi Meteorite and Cultural Heritage Center comes about. So, what will the center contain? So the center will contain the cultural and historical aspects of the indigenous people, as well as the scientific aspects of the crater. And this will be linked to ecotourism sites around the area. For example, places of geological exposures which show evidence of the meteorite impact, among others. Tourists and visitors to the site will first be taken through some lectures, documentaries, and exhibitions before going on the site visits. The indigenous people will be trained as tour guides so that they can conduct tourists around the sites. And in this way, it is envisaged that it will provide alternative livelihood for the people and thus contribute to poverty reduction in the area. So these pictures show some of the photos that I've taken at Lake Bosumtwi, a very beautiful area. And then, so in conclusion, we say that understanding of impact structures, their formation processes, and their consequences should be of interest not only to the earth and planetary scientists, but also to society in general. The biological evolution of planets is punctuated by mass extinction events, the well-known one being the impact 65 million years ago of a 10-kilometer diameter asteroid that wiped out the dinosaurs and other species. So impacts, therefore, pose a hazard to humanity. However, with the constant monitoring of asteroid and comet trajectories in space and the deployment of countermeasures to deflect them from the Earth, the impact hazard may be reduced. 100% effectiveness of the countermeasures cannot be guaranteed anyway, and the Earth remains vulnerable. Meteorite crater museums have been established at 4 sites, namely the Barringer crater or meteor crater in Arizona, USA, the Fredefort crater in South Africa, and the Ries and Steinheim craters in Germany. So a similar one can also be done at the Lake Bosumtwi crater, such as the Lake Bosumtwi Meteorite and Cultural Heritage Center. Impact craters have been found to have economic potential. For the case of the Lake Bosumtwi, its immense scientific and educational potential can be harnessed to promote ecotourism. We don't want people to go there and do galamsey and then, illegal logging and therefore devastate the environment. Because if that is done, then all that I'm talking here cannot work. Because we want to preserve the place for tourism. The Lake Bosumtwi crater and its surroundings serve as a natural environment, a natural laboratory where all kinds of research can be done and tested and then applied at other places. Therefore, the place should be protected and well preserved. So these are some references, published papers after the research and other general references. Okay, so just to acknowledge my research partners and so forth. So this research was done within the framework of the Ghanaian-German Research Cooperation or Collaboration on Geophysical and Remote Sensing Investigations of the Lake Bosumtwi Impact Crater in Ghana, with funding from the German Ministry of Economic Cooperation and Development, the German Research Foundation, the Ministry of Tourism and Ghana Tourist Board at the time, KNUSC, with logistical support from the Bosumtwi District Assembly. The research team, the Ghanaian side, we had the Department of Physics, KNUSC, Department of Geodetic Engineering, KNUSC, Survey Department, Accra, Ghana Geological Survey Authority in Accra. The German side, we had 3 universities, University of Frankfurt, University of Munich, and then University of Kiel. So at this juncture, I would also like to appreciate my mentors, my colleagues. First of all, I would like to appreciate colleagues of mine who assisted me during the field work. For instance, Professor Abuaji Menye, Professor Preko, Professor F.K. Ampon, Professor Ening, Dr. Boama, Mr. P.Y.O. Amuako, we all worked together, during the time. And then Mr. Nicholas Opoku, at one time, we also worked together on a committee at the lake. And then at my department level, I also want to appreciate senior colleagues like Professor Singh, Professor Boachi, Professor Inkum, Professor Abba Andam, who was also one time in the department. So I thank them all for the useful consultations that we used to have or are still having. I also thank my department staff, all the supporting staff, and students, past and present. A lot of them work with me at the Lake Bosumtwi, so I thank all of them. I also want to say a word to the younger ones who have come to listen to this talk. As I said, I hope you will take something home. This is applications of science. As I said, I'm a physicist, I'm a geophysicist. I did physics, I did geophysics. Geophysics is not, or I can say, earth sciences is not just for looking for groundwater, looking for minerals, looking for oil and gas. There is more to that. The only thing is that we don't have the necessary tools and other working equipment to do high-level research. But planetary sciences is one of the disciplines. It's very, very important for us to create awareness that we have space sciences, we have the planets, we have things also happening up there. And we can also harness that for our own development. So I'm encouraging you to take interest in science. Just allow yourselves. Just do physics, chemistry, biology, and the others. If you go to the university and you are given a course in geology or physics to do, don't grumble. Don't say that, why am I coming to do this raw discipline? You do it first and see that other opportunities will open up to you. See, other opportunities will open up to you. So that is my advice to you. So on this note, I thank you very, very much for listening to this.
Thank you, Nino. Thank you. Well, audience, I think we've had a phenomenal lecture on planetary sciences. And for that, I think we ought to give another round of applause for our lecturer. Now, before I attempt to, I can't possibly summarize, but a slight deviation from the norm, Mr. Salosia Danuor is going to make a presentation because he has to make a presentation tonight. It's just been phenomenal. So, Speaker, a presentation from your family, and please. Good. So although I won't summarize, there were a few take-home messages. And so what I understood is that planetary sciences are important, and there are existence of planetary objects. We've been introduced to he gave us an overview of craters and his research findings, and the introduction is that craters are major landforms, and their impact can be quite catastrophic. And there are large craters and small craters. But the largest one you have to differentiate between volcanic craters and craters that are formed by meteors. He took us through the origin of craters, the impact structure, significance, and he says there's been about 200 impact craters recognized on Earth. He gave us some historical perspectives, and that the Bosumtwi crater give us some rim size, and that after the crater, the importance of his work was doing research to understand the geophysical. The only way we can understand whether it's a volcanic or a meteoric crater is to understand the geophysical and the surface structure and the frequency of the impacts thereof. And then there were a number of, from describing the basic background of the crater, his research did a number of measurements. They looked at the geophysical, the surface structure, the frequency, magnetic measurements, and then some of their results is that the Bosumtwi needs to be zoned to protect the area. And of course, one of the things that I also learned was that as you have this meteor hitting the Earth, it releases energy. And the energy content was about 100 times the Hiroshima bomb. And that was must have been quite dramatic. And that the impacts on the Earth can be ongoing. And he also mentioned some of the oldest craters that have been formed, the one in Australia, South Africa, and Mexico, and how often these are formed. What was interesting is that we may be sitting in our bedrooms and we'll have meteors hitting us. I mean, that was quite frightening. And then the use of his findings was for ecotourism. I think that the most important thing that Professor Danuor has spent a lifetime trying to understand what we thought was, superstitious. So he says, move beyond superstition and get into the science. When you get into the science, we get educated. And the important thing is so many communities that they are educating and recognizing that they're now not afraid to go beyond the lake, but they can actually go beyond the lake and understand the usefulness of the lake being there. And then, some of the things that can be done, further research, and then the related interests of the tactiles. I've learned so much. The usefulness of his findings is the establishment of the Bosumtwi Crater and Cultural Site, the number of things that can be done, both in research and improving the alternative livelihoods of the community. So in conclusion, the science of impact structures is of interest to both science and humanity, and that we need to use the study for ways that will understand our environment and make it less frightening, so we can live with structures that are around us. So I think with this few, take-home messages, I think we have to thank the speaker for a wonderful evening and education. Thank you very much.
Okay. Thank you very much, Madam Chairperson, Professor Emerita Isabella Kwachi, for presiding over this evening's program, making an excellent summary of what is obviously a very complicated, for some of us, I believe, subject matter. We are very happy that this evening's program has been attended by our younger brothers and sisters and colleagues. We have Accra Academy and Ganata Senior High School with us. I think you've done very well. We'd like to recognize your presence, and Professor Danuor has admonished or counseled or advised you on the importance of studying science and interesting thing that can emerge from this. So I think we are very happy that you've made the time to be here. We also would like to reiterate the acknowledgements to the distinguished personalities and sponsors of Prof. Danuor's lecture that were made at the beginning. Distinguished ladies and gentlemen, organizations that have supported this lecture, we acknowledge you and we thank you very much. We would also like to say that there are a number of interesting, important lectures slated for the latter part of this year, and we would kindly encourage all of us to look into the news media and look out for these events, and you are cordially invited to attend. Professor Danuor, we thank you very much. I think your lecture has been very interesting, and Madam Chair has done very good justice to that, so thank you. First, and I think not the least, we would like to recognize all of us that have made time to be here. I think we appreciate your presence. We also want to appreciate all our colleagues and those online who are logged in and taking part in this event virtually. I have been asked to also inform all of us that there is refreshment in the foyer, and we are all invited to participate or take a pack with you when we are leaving. So we'll say all too soon we've come to the event, end of an interesting event, and we'd like to say thank you very much. Congratulations. Yeah. Right, so as is the protocol, we are respectfully asking that as the distinguished lecturer and the high table processes, we will kindly ask you to stand up. Thank you.